I mean, you know, I had a philosophical choice to do, and I decided not to try to pack a lot of material in this talk. So basically, I mean, I thank very much the organizer for allowing me to talk. This is very nice. And I just want to remember Cyrano, and maybe one or two ideas will emerge that I think could be, in some sense, useful. In this sense, you see, I could say that less is more, so one could say that less time is more material one can present, because in any case, right, you're not expected to follow, because in 10 minutes, and so I can really do what I want. But no, I will not really do that. I think two ideas I hope could emerge. One is something about the computation of replicon exponents. So you heard about Andrea. I will not go in any technical detail. That will be more a numerical talk. I mean, not even. And I think I was, this is what we were discussing yesterday with Mike, I mean, publicly, that there is something that emerged that could be of importance for the future and for our point of view about disorder system. And I think that, as usual, this is coming mainly from experimental progresses, meaning that new experiments that can be done are teaching us important things. I hope I will have 2 minutes to do that. And then the second message maybe that could be sent is the importance to use the correlation length as a basic variable. And again, this is a statement that comes from numerical simulation, meaning accurate numerical simulations, but that in the present context can be extrapolated to experiments. Let me tell you just very fast. Cyrano was an exceptional person. We all know that. I remember it really very big affection. I tried thinking about it to write down 3 points. One, his motivations were always very noble, very high, very systematic, very focused. He would have a problem, he would go and attack it with this incredible mental integrity, and he would be as powerful as one can imagine. He was always very open-minded. Okay, he spent his life working on a scientific project, right? But in any moment of his life, he was open to new comings. I mean, he would look for something new all the time. And doubt was really the basis of what he was doing. I remember, I mean, I will tell you a bit, I will have one slide about some work we did together. I see him doubting, looking again, finding again, till the moment in which he was satisfied, or at least partially satisfied in such a way that then you can continue. Surely has left us a very remarkable cultural heritage, and I think that is really a message of all of us here to remember him, that we have a lot of space for building upon that. Let me start with a point we were discussing a bit yesterday with Mike, and I will then give you details. Somehow, the main issue with the analysis of our physical systems, numerical simulation, but also theoretical ideas, right? Because when you do a perturbation theory, what you have exactly the same problem, is that we want to go close to the infinite volume limit and to the infinite time limit. And then we can debate a lot, right? Sometimes we say, we'll never do that because replica symmetry breaking will come very, very late, etc. We cannot say, and then you're a bit lost, because like if you're doing string theory, I mean, you're not doing string theory for a reason, because you believe that you want to deal with experimental physics. But what I think emerged in the last years, and I think is very important, right, is that you can have experiments in which you determine the size of the collective phenomena that are going on in your materials. Okay, have in mind the cycle experiments and say Raymond Orbach experiments in San Diego mainly, right? So you look at some susceptibilities with aging. I will not enter in the detail, and you can establish things. And for example, you can establish, this is quite clear now, that on the scale of a typical experiment, say average life of a PhD student or 100 years or what it is, right? The relevant correlation length is of order of maximum 100 lattice spacing. Could be 50, could be 100. Order of 10 to 6 spins or less do participate on realistic time scale to what is happening. In this sense, I think, and I will show you something a bit technical later on, so this is the 99, first thing that was explained in Orbach 1999 experimental analysis, and now there are some recent experiments that say that. In this sense, you see, our duty is far easier. Because at the end, I don't care so much about what happens in the very infinite volume limit, in the very t equals 0 limit. I care about what's happening in experiments. So we have to see which is the theoretical approach that better describes the time scales that we are observing in experiments. Okay, so this is more or less my first message. No, did I? Yes. I just wanted to put one slide. So I have one joint problem, and because this is, I have one joint paper with Cyrano, with Irene that is here, and then Francesco Giuliani, and that was at the time a PhD student, and Olivier Martin, in which we worked about the replicon exponent. I will go back to that. This is why I think I can quote that. Clearly, Andrea Crisanti has given us all the technical detail we could never dream to have about that, so we are more prepared. I will give you any. But, and that was, again, it was a collaboration in which Cyrano was very active. So you consider these correlation functions, and you see, you can build two gauge invariant correlation functions, right? What I call G1 and what I call G2. And if you use the results that Andrea was showing us, basically historical result by De Dominicis, Condor, and Temesvari, you will find the G12 behaving this way. So you have a power law and a constant. What Cyrano came to suggest us is that you can use linear combination of these two correlation functions to expose the replicon correlations. Basically, you can define this correlation function, and you can see, after many, many calculations, of which Cyrano was mainly responsible with Irene, that was postdoc with him at the time, that for alpha equal 2, this plateau should cancel. Indeed, two things happen. One is that the plateau should cancel, and one is that, and this took many months of discussion and way back, etc. Sorry?
Which plateau?
A plus B R to minus C. Okay? So there is no asymptotic constant. Okay? It goes to 0. This, the linear combination of these is alpha value. Also what happens, again, I don't want to go in any detail, is that at least on intermediate long time scale, you have an exponential decay that is dominating this particular combination, okay? But this, I will show it. So I just show, so there are these complicated computations, but you've seen them, I mean, how you do them in Andrea Fink, and basically, so, replica field theory was used to find that at alpha equal to this A equals 0, dominant decay mode is exponential, and then we measure numerically the plateau, and you see, okay, clearly there are, it was also, I mean, 13 years ago, is not very precise, should be here with 0, but you see clearly this is a plateau as a function of alpha. You still are getting a little positive plateau, but the result was small, is very compatible. I mean, so this is a numerical simulation that together with confirming the basically exponential decay of this particular correlation function, I mean, confirms this computation. So now, there are ideas, I just noticed that in the last 3 months, I mean, we've written 4 papers with Jan's collaboration. So Jan's collaboration is a group of people, not necessarily replica symmetry breaking oriented, very free group of people, let's say. They do numerical simulations. We've built a dedicated computer based on some FPGA, but then at the end is a collaboration in which we also discuss among us and sometimes just use normal computer to and try to match, I mean, analytic progress to numerical simulation. So this is a paper that was titled was Theory meets experiments for the aging rate of spin glasses, just in March, okay? And the main issues are, one is that if you want to get a good estimate of a dynamical exponent, the best thing you can do is to write it as a function. You see, you don't have a pointer, right? Well, yeah, and yeah, that's fantastic. That's fantastic. Old-style mechanical approach. You see, you have this asymptotic dynamical critical exponent, that indeed will depend when you do a measurement on TW, and that you can rewrite indirectly as a function of psi of TW, okay? And we will show something, I will tell you, meaning that with accurate numerical simulation, you need to include corrections, and then you can get very precise estimate. Basically, the important thing is that you can reconcile experiments and numerical simulation, okay? And then the other thing is about the role of two critical points. It is the relevant critical point for spin glasses t equals 0, and T critical, I mean, that is that's from the normalization group effect, what I would call a spurious effect. Also, I wanted to remind you that there are new precise experiments in field geometry that are very interesting, where film thickness grows to 9 to 20 nanometer. When you measure in these films, you find that correlation length will increase as the waiting time to 1 of Z, where you can estimate that at T critical, Z is close to 9.6. This is a bit at odd with, say, historical medium-scale numerical simulation, where at the critical point you estimate 6.8. So what is happening here? I want to spend, okay, now, first thing is, important things are, it turns out it's very practical to express this exponent as a function of T and the correlation length of the system. The correlation length of the system will emerge even in the other piece of information I would like to give you, okay? And you can put a leading terms, corrections. This is important at this level, but let me just show you a figure. Let us spend 2 minutes. How much time I have? Sorry.
You have 3 more minutes.
Oh, very good. So just look 1 moment. Okay, this is about the T equals 0 TC problem. Let us forget that. But let us look at this curve, because this is the main point I want to do. There will be a second point, but I will do it fast. It is the following. This is an estimate, right, of the theta exponent as a function of a scaling variable. I have no time to define it here. Droplet prediction would be that you get 0 asymptotically. Replica symmetry breaking prediction is that it is non-zero. Okay, so when you go to the scaling limit of this x going to 0, okay, you would have a field like that for replica symmetry breaking, a field like that for droplet. Now, obviously, like as we discussed today, both these fields do work very well. But I want to call your attention on the fact that experiments show now with quite a good precision that the relevant physics of the scale of years in spin glasses is happening here in between here, you see. What does that mean? That means that even if this is the correct fit, we would be dealing with a region where at all effects, this effective exponent is of order 0.26, 0.27, meaning very far from the 0 you will get in the droplet limit. Okay? So somehow this is my message about that. I think we can try and focus our discussion about, because then you have a discovery, right? I mean, if you can show that you are describing how a material is behaving, then you are done, okay? And so this is my suggestion. If I have 1 more minute, let me drop that. I will have the time. Just one thing, because Mpemba effect. I don't know if you never heard about Mpemba effect. If you not, you should know. That is a very charming idea. Originally, it comes, this is a paper that was published in '69 on educational things. It was, you see, my name is Mpemba. It's written like that because it's an educational paper. I'm going to tell you about my discovery that was done misusing a refrigerator, okay? All you know that it's not good to put hot things in a refrigerator since you shock it. But then I was, basically, I was in a hurry, okay? So I put it in the refrigerator. And what do I find is that it freezes before the material for doing the ice cream of my friends that had been nice and had put it when it was already cold. So the guy is claiming, hot material, hot water, say, freezes before cold water. This could seem utter nonsense, but somehow this statement has a long story in the literature. There is a paper, I can give it to everybody interested in, which will show you what Bacon was discussing about that, Descartes was discussing about that, Aristotle was discussing about that. They will write things about. It's very well known that hot water freezes before cold water. Okay, now people have been studying that. The American Chemical Society has had a prize 5 years ago for proving or disproving Mpemba effect in water. I think there is no Mpemba effect in water. Also, it's clear that imagining a physical mechanism that would allow that in water would be just absurd. But we can show you a very nice and clear, typical, standard Mpemba effect in spin glasses. You know, you need a collective phenomena for having a Mpemba effect. For spin glasses, no problem. Look, so this is a typical preparation. It's a typical preparation of Mpemba protocol. So we prepare one starting point at temperature 1.3 with an energy 1 minus 0.64, one at T equal 1.2 with an energy of minus 1.61. Use the energy to monitor what is going on. And when I show what is happening, you see, this is the cold system, this is the hot system, and it goes down. And why? You will know why when I tell you that the correlation length of a warm system was indeed larger at this level of preparation than the correlation length of start of a cold system. Okay, so it was hidden, but it was the cold system was farther. I'm finishing. Was farther from equilibrium than the hot system. So in spin glasses, and probably in glasses, I know that many colleagues are studying that because it's something that makes you curious. You can have a Mpemba effect. In order to expose that, you have to really work with the correlation length. This is my second message. Thank you very much.
Okay, thank you.
What was the experiment you're talking about?
Which experiment?
You said something about film thickness or...
Yeah.
What is the experiment?
The Orbach is doing them. Orbach in San Diego, Orbach group.
What are they looking, what's the material that they're looking at?
If I didn't write it here, wait. Let me see what because the material, now I don't remember, I can tell you in...
Glass or spin glass?
No, spin glass. No, sorry, I wanted to tell you, these are spin glasses. Excuse me. These are spin glasses, but let me see if, because normal is normal copper magnesium, I mean, but these films, I didn't write it here. Could be copper magnesium, say, as far as physics is concerned, but it's something different. I go back to the replicon.
Correlation length exponent Z of T. It's very unusual to have exponents temperature dependent. Is there an explanation of why you should have a temperature dependent exponent Z?
Correlation length dependent, you mean? Yeah.
No, just depending on temperature.
No, this one is the exponent. You see, it's a scaling.
No, when you write psi, it's like T to the Z. That Z in your work depends on temperature. I'm not looking at that picture. I'm looking at the picture before.
Which picture before?
Slide before.
Yes, yes, exactly. In the broken phase of spin glasses, this is what we are seeing. I mean, it's probably connected to the fact that this is only critical phase, and then you get a critical behavior that can depend from the exact point. I don't have what. A critical temper is a number that is 9 point what it is. I mean, yes, is a number, but that you should measure at equilibrium. I mean, in the asymptotic regime. Let me be more precise.
But do you have any calculation which explains why this Z depends on temperature?
I'm not presenting a calculation that says that Z. I think that in some Heisenberg model you have this effect, but I would not even be very sure about what is the situation exactly. But I think that you can give example of critical phases where this is what happens. I can quote it here as an experimental numerical finding, say.
Well, it's a very unusual situation.
I propose that we postpone the discussion to the break.
Yeah, but you see, spin glasses are very unuseful materials, right? Material where replica symmetric breaking apply. Thank you.
Thank you, Enzo.
Okay.